Okay, good. Hello, everyone. Great to see you here, the last day of Ignite. Thank you for joining us for this session. For a change, AI will not be the key focus of this session. We will be talking, in this session, we'll be talking all about increasing the scale and enhancing performance of your IaaS applications. I will refer to AI workloads, but the key focus is performance and scale. My name is Amit Srivastava. I'm a Principal Product Manager with Azure Networking. And I'm joined today with Varun Shandilya, who is Principal Product Manager in Azure Compute, and 𝗦𝗽𝗲𝗀𝗀𝗃, who is Principal Product Manager in Azure Storage. Let's just start by framing today's session. We'll focus on three foundational pillars for any high-performing cloud applications: networking, compute, and storage. Each of these pillars are critical to delivering the performance and scalability needs of your application. I think this will be the key topic throughout the session, that you have to finely tune all three of these pillars to get the most out of the session. In this session, we will explore the best practices and proven architecture, blueprints, if you will, as well as we will talk about the latest and greatest announcements which we are making in the area of performance and scale as they pertain to each of these three pillars. We'll cover each of those topics in detail. But before going there, just to kick things off, let's look at it from a canonical standard IaaS application architecture point of view. You could be running an e-commerce retail site. You could be running an AI-powered recommendation or inferencing workload. It could be mission-critical financial, or it could be critical health, life, and safety kind of application. It always boils down to these three fundamentals, which you all know. The compute runs your application. The storage persists and retrieves as required your application's state. And networking acts as the glue which connects all of these together, as well as your users, your end users of the application, whether they are public or whether they are on-premises private infrastructure. It connects all of them together. In a canonical application, you would see your compute. For example, you might be using VM scale sets, virtual machine scale sets for your applications. You might be using your microservice-based architecture could be running on something like a Azure Kubernetes service. Or for specialized roles, you might be running Azure VMs itself. These would then be talking via managed disks and object store to a storage network. This could be a very low transaction throughput kind of block storage. It could be a durable object store, or it could be a container or storage blob which you are running, where you are running your inference infra. You could be running your transaction logs. You could be persisting those over there. You could be persisting your images. Doesn't matter. And then finally, you have networking. We will focus mostly on the Ingress portions of the network. Networking is vast. There are many services. We will focus on the load balancing and Ingress sections. You could be having a global application which has reach throughout the world, and you could be using something like a front door to connect a global load balancing solution and also provide you CDN capabilities. Or you could be a purely regional application which is running a layer 4 load balancer, or something like a layer 7 application gateway which runs inside the regions. But these are the canonical architectures. The key point being that you have to make sure that you finely tune each of those to get most performance out of your applications. Some key points which you should make sure that these are the challenges which you think about when you do your design. At the networking layer, you want to make sure that your solution is capable of handling spiky traffic. It could be malicious spiky, DDoS kind of a traffic, or it could be regular, your application has launched something new and you see a sudden burst in traffic. You should be able to absorb that kind of load. That's why I always say that have our web application firewall or DDoS solutions in place so that you can handle malicious traffic, and then have something which is scales as your application needs scale. So something like a front door, which is a massively distributed platform, which can absorb a lot of requests seamlessly. Or an application gateway or a load balancer, which scales as your application requirements grow. In application space at compute, here your key concern should be that first, do you have ample reserved capacity so that you can grow these as your workloads grow? More importantly, have you optimized your VM solutions? Have you looked at the latest and greatest, both in terms of hardware and software? Varun will talk a lot about exciting announcements in this space. At the storage, you want to make sure you are using the right solutions, whether the block store, the object store, the container store, and are you using the right solution which minimizes object storage latency, for example? Yi will talk a lot about those as well. So let's get started with the networking side of the world. As I said, I'll focus on the Ingress portions. Our product suite comprises of both services which run inside the data center, as well as global geo-distributed services which run outside of the data center. Azure Front Door, for example, is running in 210 plus points of presence or edge sites all over the world and handles millions of RPS every second. In data center, we have load balancers and application gateway for catering to layer 4 and layer 7 traffic. And all of this is protected through our web application firewall and DDoS layers. So any of these products, the load balancing or the content delivery solution you use, you have the option to enable DDoS and web application firewall on these product suites. So in summary, the networking is not just about moving packets. It's all about intelligently routing your traffic. We route the traffic based on many characteristics of the request, for example, or based on latency, or based on the user geography. So it's all about intelligently routing the traffic, protecting your workloads through a WAF or DDoS layer, and scaling seamlessly. Let's go into a few best practices. I have talked a little bit about these. If you want acceleration, you should be using, or content delivery caching, you should be using a front door solution. Front door, as I said, sits at the edge of the network. Now what this means is that it's able to terminate your TLS sessions closest to the end user. So if your end user, for example, is in Los Angeles and your application is in West US, then instead of the three-way termination, like three-way handshake going all the way to West US, it would terminate in a pop right there in Los Angeles, for example. So that saves at least 200, 300 milliseconds of round trip. Front door also maintains a warm connection to the backend. So now, because there is an already pre-established connection to your backend servers, it doesn't need to tear it, like start a new connection, tear it down, start it again. It saves in the round trip around 200, 300 milliseconds just by putting front door in front. And because it also does caching, it saves your origins from a lot of unnecessary requests. Your origins are not overwhelmed. Some of those can be cached right at the network edge. And it also provides you WAF and DDoS capabilities. Now, we also have in the data center our app gateway, which is the layer 7 solution, and SLB, or Azure Load Balancer, which is our network load balancer for layer 4. We also did something very unique for Kubernetes-specific workloads. We have a specific SKU for Kubernetes workloads called Application Gateway for Containers. I highly recommend that if you have AKS workloads, please use App Gateway for Containers instead of the regular Application Gateway for VM and VMSs. So those are some of the best practices. I'm going to talk about the enhancements which we have made on the networking side. First, I'm very pleased to announce support for QUIC. This is under preview for App Gateway. I'll talk about it shortly. On the AGC space, App Gateway for Container space, we are pleased to announce load-aware routing, as well as web application firewall, which is generally available. I'll also talk about, in the container space, our enhancements and advancements with Azure Managed Cilium. So let's go into these topics. So this has been a very old ask on application gateway. When is App Gateway going to support QUIC and HTTP 3? So I'm very pleased to announce support for application gateway for QUIC and HTTP 3 workloads. Needless to say, QUIC would require TLS 1.3, so we also support TLS 1.3 and TLS cipher policies for TLS 1.3. So we have TLS policies for this as well. There are huge advantages in using QUIC. You can see faster page loads, up to 200 millisecond improvement over HTTP, HTTPS over TCP. So because it uses under the cover UDP, you can see these gains. It also provides better performance on high latency networks where you might be having a mobile client which is changing towers, or your network latency is not that good. You will see even better performance in those kind of places. Also, because it eliminates that there is no head of line blocking, you don't get multiple streams concurrent blocking each other. So it also reduces the head of line blocking, improves your application performance. So this is ideal for real-time applications, transactional systems, or any kind of scenario where every millisecond counts. So you can enable this at a per listener level. And with this, we now support HTTP 3, HTTP 2, and HTTP 1.1. Linda is here. She is in my team and runs the App Gateway. If you want to get enrolled in this preview, please reach out to her. Going forward, let's now talk about traffic distribution. The key thing of load balancers is that how does it distribute traffic to all of your containers or VMs effectively? You don't want to see uneven distribution of traffic. You don't want to have containers which are lying idle, whereas other containers are getting hit with many requests, and a request queue is building up on those. So I'm very happy to announce a preview on application gateway for containers. We are rolling this out, actually, and by the end of this month, you would see it start appearing in most regions. But given that how critical this is for ML workloads or really high throughput workloads, we are very excited to announce this. Now, I'll just talk a little bit about how it works, and we also have a demo on this, which we'll do. So what it does is, traditionally, all App Gateway or App Gateway for containers looks at a round-robin distribution or a weighted round-robin distribution or distribution based on request header or URI path or some query string parameter. But these are what application owner has to do. They have to decide, okay, hey, this is how I want to route. And there is not a lot of flexibility in these. With load-aware routing, the load balancer is looking at the backend load itself, and it is making real-time decisions on how to distribute the traffic. How we do that is through Orca load report format or open request cost aggregation load report format. The backend, in response to any request, it could be health probe requests as well. In response to any kind of request, it sends its current load. It could send its CPU load, GPU load. It sends a decimal between 0 and 1, and that gives an indication of how loaded that backend is. So it's an open format. It allows us flexibility. You could send just one field which says, let's say, my overall health. Or you could send CPU, memory, GPU, NIC scale. You can send all of those, and it will, at runtime, determine which is the most loaded based on those fields which you send back, and it will distribute the traffic accordingly. So it avoids hotspots, and it sends the traffic to the least busy workloads. Let's keep moving forward. Application Gateway for containers has been the replacement for App Gateway Ingress controllers. I sincerely hope that you're not using AGIC anymore. We have strongly recommended people to move from AGIC to AGC. One of the challenges of moving from AGIC, which runs, which is the Ingress controller for standard application gateway, one of the challenges with that was that it did not support, AGC did not support WAF. So This had been the #1 migration blocker from AGIC to AGC, which is what we want. So we are very pleased to announce that we have unblocked that. Now, you can run web application firewall on AGC. In fact, you can use your app gateway web application firewall policies and move them directly to AGC. So that mobility is also there. Okay, let's keep going. So this is seamless policy management, centralized security. And finally, we have been steadily enhancing our Azure managed Cilium. So AKS customers get more observability, more secure data plane path without any operational burden. So we are doing this through eBPF-based data path integration and acceleration. On the same environment, you can bring your own Cilium, or you could use Azure CNI powered by Cilium. If you use Azure CNI powered by Cilium, we measure 49% improvement in performance, which basically translates to eliminating your latency, more headroom for your compute, and it's very suitable for AI inferencing, chatty microservices, and data pipelines. So under the hood, it is executing this in eBPF, it is doing the hardware offload, it is avoiding the dual in-cap, decap overheads, and all of that results in 49% improvement in performance to any calls. So I would strongly recommend that use this, give it a try. It's in preview. We will be doing GA on this soon as well. I just want to take a quick 30 seconds to mention some other notable announcements on the app gateway side. We announced TCP TLS proxy last year. It was in preview. Now we are announcing GA of TCP TLS proxy. So on the same app gateway, on the same public IP, you can do L7, HTTP, HTTPS workloads, as well as you could use a TLS proxy for your non-HTTP workloads as well. So that is going GA. With security, we wanted to increase our security posture, so we do JWT token validation directly on app gateway now. We have also included a WAF DDoS rule set, and AGC now supports CNI. We have G8 slow start, slow ramp up algorithm, and Istio mesh integration. So AGC can serve as the Ingress gateway for your Istio mesh solutions. With that, let's go into a quick demo, and then I'll hand it over to Varun. So let's demo the load-aware routing, which I talked about. The demo gods are not happy. Okay, let's just give it a second. One more. Okay, there we go. So in this demo, you will see that there are 3 pods over here which are idle at this point of time. They are not taking any traffic. They are taking, all the requests are going to them, but they are idle. So the requests are going to all 3 of these pods, 6C2, Z15, and QJS. We are continuously sending traffic to all of these pods, and you can see that all of those pods are actually receiving traffic. Now, we'll try to put some load on this application. So this is a very simple application where we are drawing a figure, and then we are using an AI model to generate an image out of it. So let's do that. First, we will do a low resolution, like it will not put a lot of load on the back end. Pardon, I'm not Picasso at all, but let's go with it. So we'll try to generate, and because this is not taking any load at all, you will see that it has generated a very simple image, and all of those are still taking the load. Now we try to do a really high resolution, and we have increased the fun factor, so to speak. And now you can see that this particular the one which is ending in QJS, is taking 100% load. And now if we are sending additional requests to those, that QJS is not getting any request because it is pegged at 100%, whereas the other 2, which were at 0%, continue to take the load. So this basically gives this particular pod breather while it generates an image, while the other pods continue to serve the other ongoing requests. So thank you for that. With that, I would want to hand over to Varun.
Thank you, Amit. Can you hear me? Yes? Awesome. So I'm Varun. I'm going to talk about compute. So now you've got all the requests. You got to do something with them. So let's talk about how can you use compute more efficiently, how can you scale, get the best out of compute. So we're going to focus on the application layer and what we have across different compute layers, which is virtual machines scale sets, and advancements in Kubernetes. I'm not going to dive into Kubernetes, but serverless containers aspect of it. Some of the best practices that we will cover in this topic is always start from latest generations. I know it's sometimes hard to keep track of what is coming new, but Ignite helps with that. We also are trying to make it easier for you to adopt these. Instance mix kind of plays into that, where you can mix different SKUs and capacity that you need. So it basically simplifies ability for scaling out using the latest SKUs or the SKUs of your choice. Deploying application at scale is also very critical. And with VM apps or VM applications, we are simplifying that aspect. We are also increasing the scale on how you can deploy your applications and be more resilient. Last aspect, which is not going to be covered in this talk, but I'll just touch on it, which is security and resiliency. Always make sure that you're using multi-AZ deployments as much as you can for high resiliency. For delivering your images, use Azure Compute Gallery, which is a reliable way for you to create your VMs at scale across different regions. We also have, for Windows customers, hot patching, which is zero downtime updates for security that we deliver, so reducing the downtime in that aspect. And also Resiliency Hub, which helps you to be resilient and takes a workload view and then helps you guide through the best practices, with the idea of start secure, stay secure, and resilient by design. So we both have to play a role in this, because you would have to adopt these and then we deliver the value. Now let's look at the application layer and what we have to do in that, and like what we'll cover. So I'll cover like new VMs. I'll talk through Azure Boost and update or new innovation that we're bringing in the virtualization layer with direct virtualization. I'll also talk through instance mix. It's more of guiding you and helping you understand how to best use this technology. We'll talk about schedule actions, which is tuned towards AVD or VDI type of scenarios or virtual desktop type of scenarios, but we plan to enhance this to cater to other scenarios as well. And then lastly, we'll cover large serverless containers on how you can use serverless technology for your AKS deployments. So let's dive into it. So for the new VMs that we're launching, we are always pushing the envelope, working with the vendors. So the V7s and the V6, we have a new network optimized series on starting with DN. We've also launched a new AMD-based F series that will be available, and we have new storage optimized series, all of them built on the latest 5th generation AMD EPYC and Intel Xeon 6 Granite Rapids. We also have new confidential VMs on the 5th generation Intel Xeon as well. There is a session right after this with Stephanie Lemon and Max, who are going to dive into both VMs and their capabilities and Azure Boost. With Azure Boost, so Azure Boost is our hardware platform, which enables high throughput up to like 1 million managed disk IOPS, which is 1.6x faster than what we announced at build, and we're constantly pushing this boundary. With network, you can get around 400 Gbps of throughput. Maintenance has been a big issue for customers, where when we do maintenance, there is a brownout and whatnot. With Azure Boost, what we're doing is we are enabling dual TOR, which is top of rack, where if we have to update one of the top of rack, the traffic goes to the other one. So you see a sub-second non-noticeable updates when we do that. And Azure Boost is also our platform for HPC and GPU scenarios as well. And Max will go into deep details about Azure Boost and the innovation that we're doing there. So if you're interested, you should definitely attend that session. So looking at all the silicon which is out there, So we have Cobalt 100, which is in Microsoft-based ARM chip. The V6 series are based on that. It gives 50% better performance than the other competitors or the earlier ARM-based chips that we have. And we're pushing the platform forward. You might have heard about this in earlier talks as well. With AMD, you also get like 15% better performance, and similarly on Intel. Now, where does it come into play, and how could you use this? So that is where virtual machine scale sets instance mix comes into play, where you could mix different SKUs together in a single deployment. So many times, there are 2 or 3 SKUs which fit the performance portfolio that you have. And you want to make sure that you can get capacity, because getting capacity in hot regions sometimes becomes a challenge. So let's quickly look at the demo of how you can do this. So in this demo, what I would be doing is I would be selecting certain set of SKUs. So in this case, I'm in WestUS 3. I've selected all 3 zones. From a resiliency standpoint, I'm scaling to 20 instances. I'm using the flexible mode. But here is where's the interesting bit, right? Like, so I have 4 or 5 SKUs which are listed. I have 4th generation D series, I have an F series, because those SKUs fit the performance profile that my workload needs, and I don't particularly have a preference of what I get. I can define the preference through a priority. So if capacity was available for everything, I will always guess priority 1. If not, then we go down on the priority. So you always are assured of getting the best SKU for your workload. And as it will go through, what would happen is we will do real-time capacity checks for the deployment that you're making and give you the right SKU so that we can fulfill your capacity. Our goal is to fulfill the capacity that you have asked for and go from there. So the deployment is going through. You will see all the instances showing up pretty quickly here. So I can see like all the 20 instances are there. And these instances are of the same type. In lieu of time, I'm going to skip forward, but these instances are of the priority 1 that I had defined in my initial setting. If the instances were not available, we will go to size 2, and then from there, we would kind of go to 3 or 4 as an option from fulfilling the capacity. I'll wait for it to quickly finish. So as you can see, like I got all the DB4s, which was the intended size that I wanted to get. So the next topic that I wanted to talk about is pretty tuned towards the virtual desktop type of scenarios, but it could be used in different places as well, which is schedule actions. What you can do here is you can start, stop, hibernate up to 5,000 VMs at a schedule. So you can say, I want to start my VMs at 9 a.m. in the morning, and then we work with all the underlying infrastructure services, compute, networking, storage, to make sure that we can provision or start these VMs at 9 a.m. And if you want to deallocate in general, like in the use case scenario, your workforce comes at 9 a.m. or 8 a.m., you want to make sure that, the VMs are up and ready, and 5 p.m. they leave. So you want to have like an hour buffer and say like 6 p.m. I want to, from a cost optimization standpoint, hibernate these VMs. You can do that. You can set the schedule. Right now, it's one schedule only, but we are investing to make this enhanced by having recurring schedules so that you don't have to configure them. So you can say every day at 9 a.m., I want to start these VMs, or at 6 p.m., I want to hibernate. This is a great way to save cost and get performance without you, and scale without you have to deal with these schedules. And we'll also add create and delete functionality with this. And we're also going to be adding things like having access to multiple SKUs so that you have better capacity footprint. I'm going to skip this demo just in interest of time. I want to make sure that you can also hear amazing storage innovations that we're doing as well. As part of pushing the boundary forward for container workloads, we are also introducing large container sizes for serverless. This is on Azure Container Instances. Today, you would be able to do only 4 vCPUs. Now we are improving that and enhancing that to 32 vCPUs. and up to 240 gigs of storage, of memory. This helps you to do more with the containers that you get. So you are able to pack more things into the container versus having deploying multiple containers and work through those. So it works very well for data inferencing if you have to push the boundary in that. Also, for big data processing, we have many customers who are using this for that. And the idea behind ACI or Azure Container Instances is it's a serverless technology, so you don't have to manage the infra. You just deploy your container, and we run those containers, and you put networking around it, and you get the benefit out of it. It's integrated with Azure Kubernetes services, so you should be able to use it seamlessly with your Azure Kubernetes deployment. You don't have to do something different to access this. Lastly, I wanted to talk about the advancements that we are doing in the Hyper-V space. So up till now, you would be using nested virtualization, where you create child VMs in your VMs, and then those child VMs access the host resources through the parent. So there is a performance penalty that you pay. So we are improving that with direct virtualization, where the child VMs can access the host resources directly, giving you near bare metal type of performance on Azure VMs. So this works very well if you want to have direct hardware accelerators like GPU and NVMe disks, and give that access directly to the child so that they can access it. It also is very useful in a multi-tenancy hostile type of workloads, where you want to have two hostile workloads running together, but secured through the isolation boundaries of Hyper-V. It also gives you better throughput because you can save your data on the VM, and your child VMs can access that data directly, giving you higher throughput, and works very well in AI type of scenarios. I know Amit talked about we're not going to center it in AI, but you got to mention AI. So you could basically have your large data models sitting on the VM. So you create a VM, you have a large data model sitting on the VM, and you can have like your inference or agentic workloads running as child VMs, having access to that large data model, have high throughput because the data is cached, and then your devices or your inference workloads or agents can have access to NVMe disks or GPUs so that you can do meaningful work with it and can scale through that. We're pretty excited about this. This is in very early preview, so if you want to be part of this, please scan the QR code, and we can help you with this. We will get this into availability next year. Lastly, quickly just talking on this, on Azure VM applications, it is the way to deploy up to 25 applications onto a VM. You can have regional replication, so you can just deploy once and it will replicate across regions, so you have availability to your applications across different regions as well. With that, we're running low on time, so I'll invite Yi. Thank you.
Thank you. Thank you, thank you. Good morning, everyone. Let's jump right into the final pillar, storage. Tight on time. So Azure Storage is not just a place to keep your data on the cloud, right? It is the backbone of how customers like you can extract value out of your data. Today, I want to share, click too fast. Today, I want to share some best practices to meet the performance scalability requirements for some of the most demanding workloads. I will use examples from AI and mission-critical workloads. Let's start with how we're meeting the performance needs of this ever-growing, hot topic on AI training. Storage accounts, I hope you're familiar with that. They were once limited to a single storage scale unit. So this means that you're capped on capacity and throughput. For most workloads, that was OK. But as AI data sets push into exabyte, right, these limits have become a real constraint for customers. To scale, traditionally, we have asked you, customers, to create multiple accounts and play around to shard data across them. That is no longer necessary. When a storage account approaches limits, it now spans multiple scale units underneath automatically, right? So capacity and throughput grow as needed by your workload. This is all handled entirely in the backend with no additional configuration or no additional cost for you. Using blob storage for workloads that demand this massive capacity and high throughput has always been the best practice, so I will not expand on that more. But I do want to give you one additional tip today. Keep it simple. You don't need to shard across multiple accounts anymore. Right? Consolidate your workloads into fewer accounts designed for growth. This reduces operational overhead for you, simplifies monitoring, simplifies governance, and ensures the application scales smoothly as the data demand continue to climb. You probably have already seen this detailed demo from earlier sessions, but by leveraging scaled accounts, blob storage can deliver several tens of terabits per second throughput on exabyte scale capacity. This is truly unprecedented cloud storage performance for AI training. Guess what? This is not the max, and this is nowhere near the max. Right? So I challenge you to use your workload and see how high of a throughput and capacity you can get. Another critical stage of AI workload I want to talk about is inferencing. With the latest AI models growing in size, they simply do not fit into a single GPU's memory anymore. So the solution here is distributed inferencing. To do that, you need a solid high-performance storage solution to back it up. Well, a great choice are these local storage on the VM that you're already paying for, right? So you want to serve large models repeatedly, not just for AI, but any other similar containerized workload. You can benefit from the low latency and high IOPS of this local storage at no additional cost. But this is another area where we want to help you. So Azure Storage is driving innovation here to support robust, stateful, containerized workload. Azure Container Storage is a managed storage offering. It's tailored for Kubernetes. It provides a common abstraction over multiple storage options that are not normally supported by the CSI driver. One example is the local NVMe drives. I'm excited to announce that version 2 of the Azure Container Storage is now generally available. This particular update delivers 4 times less latency and up to 7 times better throughput with the local NVMe storage compared to previous versions. This is extremely fast. To give you some example, right? Even a small 8-core L-series VM can deliver 400,000 IOPS. And our top-of-line VMs with local NVMe delivers up to 6.6 million IOPS, and all at near local sub-millisecond level latency. So putting this together, Azure Container Storage allows you to run these local NVMe storage and turn them into persistent volumes, right, for your Kubernetes workload, which can then be used to quickly load models into the memory and then into the GPU. So my second recommendation is for you to go back and try this Azure Container Storage with local NVMe drives. The benefit of this setup is not only to allow you to fully harvest the high performance of the local drives, but also converts these ephemeral disks into persistent volumes so that this workload can survive pod restarts, survive config changes, and version upgrades. This is an example of a performance measurement of model loading time for the popular Kaito distributed inferencing framework. And with Azure Container Storage supporting, striped across two local NVMe nodes. And you can see that Azure Container Storage is significantly faster because it leverages the high-performance local storage to download load models rather than relying on your other solutions like host OS or host data disks. So on that note, let's turn our attention to foundation of the enterprise storage. Mission-critical workloads. That's what I'll talk about next, right? Such as Tier 1 databases and transaction system. They require consistent and scalable performance. Here are some best practices to optimize Azure disk performance. First of all, no-brainer, it is critical to select the right VM size and disk configuration. Right? You should consider memory, CPU, latency, IOPS, and bandwidth. If any of these aren't set correctly, you will not go beyond what either the disk or VM can do. On that note, we have disk performance for Azure Copilot. It is now generally available. it can help you review some of these selections to optimize for performance. You can further boost efficiency by assigning workloads to separate disks according to their operational pattern. One example is that you can assign a dedicated disk with very low latency for database logs so that you're optimizing for its write-heavy operations. One out of the storage portfolio, one service that's really good for this is our top-performing block storage solution, UltraDisk. It is designed for applications needing predictable low latency at high performance. So I'm super excited to announce that we are relaunching Azure UltraDisk today. It is more powerful than before and supports a wider range of workload characteristics. For mission-critical workloads, we all know that even a brief disruption can have significant impact. So we have worked on reducing the average latency by 30% and the frequency of the outlier latency by 80%. At the same time, we also doubled our max performance. UltraDisk with the new general-purpose EBv6 VMs can support up to 800,000 IOPS and 14 Gbps. UltraDisk is ideal for high I/O and latency-sensitive tasks like database logs. So here's another best practice. If you are using local disk today or write accelerator in Azure to achieve lower latency, we recommend you to try UltraDisk as an alternative option for enhancing data persistence and also get greater flexibility out of it. In mission-critical environments, operational efficiency is just as vital as performance. UltraDisk now supports this new feature called Instant Access Snapshots. Let's take a closer look at how Instant Access Snapshots helps with scaling your workload. So a snapshot is a point-in-time capture of your data. It is stored on standard HDD disks to keep costs low. As you can see in the diagram, when you take a classical snapshot from UltraDisk, the system starts a copying process of the data to the standard HDD. Normally, you must wait for this data copy process to finish before you can use the snapshot, which can take several hours depending on the size. With instant access, there is no waiting time. We still create the snapshot on standard HDD, but we also add a pointer to the source disk, so the snapshot is immediately available to create a new disk. At the same time, right, this new disk created from the instant access snapshot hydrates faster, and they operate with minimal performance impact. What this means is, consider a classic scale scenario. We have e-commerce customers who have to deal with the painful process that their customer have large traffic spikes. They need to be able to quickly add servers to help distribute the load and maintain performance. When that timing is critical, instant access snapshots are usable right away to create new disks. And these new disks are ready to run production workload from the start. And finally, I want to touch upon data integrity. It is an essential part of enterprise apps. And torn write can really compromise it. So torn writes occur in the event that you have a power OS failure. You will interrupt disk operations, leading to partially written blocks. Database now operates with larger and larger pages, so they are very vulnerable to torn writes. Traditionally, database engines rely on software methods to avoid torn writes. For example, Postgre has full page writes. MySQL has double write buffers. These add considerable performance overhead and increase application latency. So did you know that Azure manages natively prevent torn write? Our managed disks guarantee atomic writes for 8 KB and 16 KB blocks via the NVMe controller. This eliminates the need for software prevention. If you're running Linux 6.13 version or newer, as best practice, you should disable traditional software prevention to significantly boost performance. So for example, doing so on MySQL will reduce your latency up to 47% and increase the application throughput by 90%. I made it just right there. So wrapping up with 4 seconds to go. But I will skip a wrap-up section. Yeah. There, I'll just I'll just end this by saying that, leverage all these solutions in the right scenarios. It will really help you maximize, your workload. Yeah. Thank you.
Thank you, everyone.
Thank you for being here on a Friday.